Pressure from the cardiac cycle enables us to measure the pulse of our finger. This technique is easier to record and is nearly as accurate as taking a pulse from the carotid artery. For the finger pulse technique, an instrument called a transducer is placed over the finger. The transducer measures the speed when the pulse moves between 2 points. This measurement, along with a person's body mass index and age, demonstrates whether the main artery is hardened. Both an alternating current and a direct current may be seen in this practical. DC, a constant, is traceable to the bulk absorption of the skin, while AC is traceable to the blood volume in the skin induced by the pressure pulse of the cardiac cycle. These small variations, the changes of light intensity due to blood flow into or out of the finger, are the signals we want to see. Therefore, we amplify the AC component. To amplify the AC component, we use a low-pass filter, and to silence the DC component, a high-pass filter. We began by setting up a reflective optical sensor. To see if the sensor worked, a cell phone camera was directed at the sensor to see if an infrared light could be observed. If the light was observed, the sensor worked. Infrared rays are invisible to our eyes because the human eye cannot detect wavelengths of a certain range, but some cell phone cameras can. It is necessary to filter and amplify the circuit to get the correct output and the best results. We filter to get rid of all the unwanted frequencies like noise and other possible things that might affect the sensor. Then by amplifying it, we are amplifying the wanted frequency that is limited by the cutoff frequency. By adding another round of passive high-pass and low-pass filters, we are amplifying the circuit one more time to get a more accurate result since we are adding another round of gain. Therefore, the total amplification is 101 times 101. The passive high-pass filter is non-amplifying with a cutoff frequency of 0.7 Hz. It filters out all the frequencies under 0.7. The active low-pass filter is an amplified filter with a cutoff frequency of 2.34 Hz. It filters out all the frequencies above 2.34. By connecting them, we can get a response from frequencies between 0.7 and 2.34 Hz. The correct resistors and capacitors need to be calculated by using the given cutoff frequencies. In this graph, you can see how the frequency is filtered by the given cutoff frequency. It shows how the filters work by cutting off unwanted frequencies. The gray area shows the desired frequency band that has been filtered to get the best results. The negative 3 decibels is the cutoff frequency, which is 30% dulled. Now, in part 2, we complete the photoplethysmography by adding a 4-bit counter and a 7-segment LED to the circuit. By connecting a push button to the circuit, we can control the count by resetting it when pressing the button. A normal resting heart rate is somewhere between 60 and 100 beats per minute. Many factors can influence the heart rate, including emotions, temperature, body position, physical activity, body size, level of fitness, and nutrition. Certain beverages have the ability to influence your heart rate, either slowing it down or raising it up. In this experiment, we put a teeth tie around her finger to get a complete loss of circulation in the finger. The teeth tie is small and narrow and therefore ideal to use for this exercise. The finger quickly became white, which is a sign that the blood flow is slow or nothing. The finger gets cold and blood flow and circulation to your hand is reduced and may cause problem for the oximeter to detect a good pulse signal. When this happens, a pulse oximeter may take several minutes to return a reading, and sometimes the reading may be inaccurate. We recorded for 30 seconds and only got 2 pulses. Now Rannveig's pulse was measured after putting an elastic band on her finger to restrict the blood flow. Now we should call the doctor because only 1 pulse was recorded in 1 minute. Inga decided to drink a caffeine drink called Nocco and contains 180 milligrams of caffeine. In order to realize the caffeine volume, there is about 95 milligrams of caffeine in 1 cup of coffee, so 1 drink of Nocco is like 2 cups of coffee. She drank the drink in about 20 minutes, then waited for 5 minutes before putting her hand on a meter. From a previous case where her resting pulse was measured, she had 66 beats per minute, and after the caffeine drink, Inga's pulse was measured 71 beats per minute. Then Rannveig decided to drink a caffeine drink. Same, she drank the drink in about 20 minutes and then waited for 5 minutes before putting her hand on a meter. Before, her resting pulse was measured 49 beats per minute. However, after the caffeine drink, her pulse was measured 92 beats per minute. Here we can see Guðrún doing burpees continuously on for 2 minutes. Burpees is a full body exercise using strength training and as an aerobic exercise. We decided to let Guðrún do this exercise to get the pulse as high as possible. After 2 minutes, Guðrún sat down in a chair and put her finger on the meter to measure the pulse. It took some time for the meter to start, but it may have been because she was exhausted and was over-breathing a little bit, which is called hyperventilation. Hyperventilation occurs when the rate or tidal volume of breathing eliminates more carbon dioxide than the body can produce. Therefore, it might take some time for the meter to begin to count. A person's heart rate should be high when exercising, but it shouldn't stay high after stopping. The heart rate should begin to return to normal immediately after the exercise, but it can take hours to fully recover. A typical decrease in heart rate is in the range of 15 to 20 beats per minute. A heart rate that decreases quicker than that is a sign of good cardiovascular health. However, a heart rate that drops by fewer than 12 beats per minute is a sign of poor health. Your heart rate recovery should gradually increase over weeks and months with regular cardiovascular exercise. Here is Guðrún's pulse 92 beats per minute. Then Inga did jumping jacks, an exercise also used in strength training, for 2 minutes, and her pulse increased from 66 beats per minute to 92 beats per minute. Right after she finished the workout, she sat down on a chair and her pulse was measured and it showed 85 beats per minute. Again, we tried after 1 minute and her pulse was a lot better, or approximately 106 beats per minute. This might be due to restricted blood flow to the fingers right after the workout, since her breathing was quite heavy. This shows that it's better to wait for about 1 minute after the workout to measure her pulse. The final results showed that her pulse was approximately 92 beats per minute. When Inga and Guðrún are compared, their relaxing pulses and the workout pulses are quite similar.